All right, let's talk here today about a little bit about what are called exponential functions. And I've written here the basic formula for an exponential function, and just talk about a couple of differences in what we previously talked about. So f of x function, in this case, equals b to the x. B is just a number, so we've got a number raised to the x power here. And so let's talk about what is different about that. And so one of the functions, the basic functions we had previously, the squaring the quadratic x squared parabola. So key difference here between that and what we're talking about now is notice here where the x is, instead of being the number that we square here or doing the operation to, the x is the power. In other words, x is in the exponent, hence the name. Then exponential function, because that's the distinction made on exponential functions, is the x is going to appear in the exponent instead of like here it is in the base. And so the base here is just going to be a number, and we'll look at one specifically here in a second. But yeah, so to be an exponential function, your x is going to be located there in the base. And so just a few things about what that will mean then to these functions. So just taking a look at one particular, so let's just go with about the easiest one, I guess. F of x equals 2 to the x. And so if we use our function notation here, let's talk about just evaluating a couple of these with the number there. So yeah, so that just means our input value is 3. We want to take a look then at replacing the x. That just means input the x to be 3. So we've got 2 cubed, which means, of course, that's not 2 times 3. 2 cubed is 2 to the third power, 2 times 2 times 2, 2 3 times, if you will. Of course, this one we can evaluate without using the calculator, but just say a word here. So if I'm going to put this in the calculator, which a lot of these we're going to have to, because they'll get a little more complicated. The numbers be a little more complicated, but just say a word here. So on the calculator, to get that 2 to the third power, locate, if you're not familiar there, yeah. Of course, we've done it with the x squared, so we're using those again. Either that button, that's what it looks like on my calculator. There might be others that look something like x to the y, or y to the x button. So yeah, we're gonna have to use that a lot there in these problems. So anyway, put that in 2 to the third power, you're gonna get 8. Now let's talk about this one. -2. F to the -2. So that's 2 to the -2 power. When you punch that on the calculator, you get 0.25. But let's talk about, so if you may need to have that in a fraction form. So let's talk about that. Why is it 0.25? Well, the negative power here does mean, what that means is that the negative power, it flips it. Basically, in a nutshell, easy way to put it is it flips it. So 1 over a 2 to the -2, another way to think of that is that flips it over and makes it 1 over 2 to the +2. negative puts the power in the denominator there is 2 squared, and so then of course you square the 2 out, you get 1/4, and those two are, they're synonymous answers. Sometimes though, they will prefer one there over another. Okay, so 1/4 or 0.25, depending on how you need to input that. Just pay attention to what they ask for. All right, so let's think about another one there. Let's do one more of those. F to the -5. Okay? So that's 2 to the -5, plugging the x to be -5. All right, and so if we want that fraction form, if it says give it as a fraction, then let's do this to it. So that's 1 over, flip it over and be 2 to the +5, so it's 1 over 2 to the +5, so that gives us 1 over 32. And then, if you do need a decimal, you can use the decimal form of that, but I did want to mention about that. Sometimes it does want the fraction form instead of a decimal. So, all right. Now, go ahead and continue on with the f of x equals 2 to the x. What about the graph there? Well, kind of like we did with quadratics, the x squared ones. Let's do a little table here. We've already got some values. I don't know if I'll use those particular ones, but yeah. So let's do the -2. X is -2 to +2. Let's do those values. Matter of fact, let's tack on a 3 to make it even more pronounced here, what I want to show you. All right. And so x is -2. Let's do all those. And, we've already done the -2. So the f of x is to the -2 then. So that's our 0.25. And let's go ahead and use the decimal form of this one for the y value there. And then on the -1, x is -1. Of course, that's going to give us 0.5. 1 over 2 to the first is 1/2, 0.5 for that one. Then x is 0, so I have 2 to the 0. I haven't mentioned this yet, but what is anything to the 0 power? Anything to the 0 power is 1. That's right. All right, so x is 0, we get y, where f of x is 1. And then, of course, these are just the standard powers of 2 there, 2 to the first, 2 to the second, that would be 4, and then 2 to the third. Go ahead and put that out there. That is 8. All right. Well, putting that in the graph here then, what we'll see, all right, so we've got x is -1, -2, +1, +2, +3. Those are my x values. So putting those all up here. So -2.5, so just a quarter up there from -2, and then -1 up to 1/2. Then at 0x, we're at 1y, 1, 2 for my next point, 2 and then 4. That jumps it all the way up here, and 3 jumps all the way up to 8. All right. So, connecting the dots there, kind of see the trends here. So yeah, pretty clearly we can see if we did the 4, that's going to jump to 2 to the 4th, which is 16. So yeah, these values are going way off the chart there pretty quickly. up, and away they go very quickly up there. Whereas over here, all right, so one thing about this one, so if we think about it, the negative powers, those just flip it over. You don't get a negative number here for these negative powers. You get the y values are positive. That's always true. So yeah, so these Yours is going to continue kind of, they'll never go negative. They'll just continue to be hover right there above the x-axis. So anyway, this is the shape we get. A little different shape. It isn't the parabola of the x squared, or obviously it's not a line either. Got a little curve to it. Sometimes they call it kind of a hockey stick for these basic exponential graphs. Hockey stick graph is what you're going to get on those. Anytime you have something similar to that, 2 to the x, 3 to the x, 4 to the x, along those lines, unless you change something else about it, that's the shape you're going to get. Y or f of x equals b to the x. You're going to get this shape, basic shape here, hockey stick. B does, for this, you know, to actually work like that, it does, you do have to have the b base greater than 1, but other than that, that's what it's going to look like. Basic shape of your exponential graph, 3 to the x, 4 to the x, that's what it's going to come out looking like. All right?